everybody, Steve here with Fun. I'm here at the Greater Boston District event, and I'm here with 6201, the Highlanders, who are currently sitting ranked 2 at this event, right? All right, these guys are doing awesome. We're here, we're gonna talk about their awesome elevator, their really sweet coral. They are at the loading station for like absolutely 0 time. And then finally, we're gonna talk about some of their really interesting software controls that they put in the elevator. Now I'm here with...
I'm Roop. I'm Garen.
I'm Allison.
I'm Miles.
And I'm Nye.
All right, let's jump in and see what makes this bot so great here at this event.
So this is our climber that we use to climb the deep cages at the end of every match. Our priority for that is to be able to get in quickly to the cage, latch on, and then pull down and be off the floor without straining the motor too much. So the way we do that is these static W plates that will guide the cage in, where it pushes past this hook, which then springs back. There's just a piece of surgical tubing here that goes around the back and through to each individual side of the hooks, and they just pivot on bearings here. Then once we have the cage grabbed, our next task is to pull in, right, so we get off the floor. And that's handled by this chain reduction here, down into our max planetary gearbox on our Neo, right behind this cover. And so this is a 135 to 1 reduction in the gearbox, and then a 2.5 to 1 on the chain, which lets us drive this with enough power to pick up the robot, and then some. And we'll bring the climber down past these black passive latches, where they will spring out of the way and latch onto this catch plate on the top of the arm. Can we go and latch it? So, huh? Yeah, and just latch it too. So they just, as you saw, spring out of the way to the side and then latch back on top.
These are the 3rd iteration of the deflectors. We started with just the hooks and determined it wasn't wide enough to catch the entire cage most of the time. So then we added very long pointy hats onto the hooks, but those flopped around too much and we were having trouble getting it to latch. So we decided that a static deflector was the best.
Cool, and are these just like 1/4 inch acrylic, or are they some special material?
These are 1/4 inch Delrin, just for advanced strength and flexibility, and acrylic parts we didn't want to shatter, so we went with Delrin. Lots of Delrin here, and then the latching tabs are also Delrin.
This is 1/2 inch solid aluminum that's welded on 3 sides because our previous design prevented welding it on a 4th. And then we made the dog bone aluminum after we had several acrylic ones shatter.
And this part is just to keep the 2 shafts spread apart nice and thin so that the cage can still fit through, but we also don't, droop our shafts and lose chain tension. We tried acrylic and settled on aluminum because it will bend without shattering.
Cool. Doing some Young's modulus analysis there?
Just a little bit, yep. Lots on the tops up here too. Yeah, all over the place, the stress strain curves. So that's a fun thing to get to learn more about.
Yeah, fun. It was like my least favorite part of college, but okay. Cool. All right, let's move on to your intake here, which I really love.
Okay, so this is our cola system. It's basically just this big bucket. Going into the season, we knew that we wanted to make this part of the robot as simple as we could because we knew the deep climb was going to be a pretty big challenge, and this group of students has never built an elevator, so we were trying to really design the core mechanism with simplicity in mind. So that's why it ended up just being this ramp. We shoot all 3 levels, really, the upper 3 levels, at a constant angle of 25 degrees. There's a driver camera down here, which helps alignment. And then it's just these wheels here that actually eject it. This setup here is released by this sort of little haul thing so that it drops out once the match is started and we've spun. This extends our catch range by a good deal, and it means that if there's a coral between us and the station, we can still get it in. So it feeds horizontally for the most part. Vertical does work. We prefer it this way, generally speaking. Goes in, slides down. Gravity does all this hard work for us. We're able to package it in a much smaller space because all of our climber designs that we were thinking of needed a lot of space at the back of the robot. So we wanted to make the elevator as far forwards as possible, which is why holding it this way made a lot of sense for us. These here allow it to be knocked over if it does end up standing up. It doesn't really, yeah, you can demonstrate that as well. Yeah. So that was one of the really only failure points we discovered while building this, so then these accounted for it really well. You can disable.
Cool. And so going back to this, because I think this is not
Yeah.
something that every team would notice. So when you guys spec this, you spec it to actually go beyond the face of the bumper, right?
Yes, by
Cool.
just a
So
bit.
when you know you slam up against the wall, it just sort of automatically adjusts and gets you the exact
Yes.
right
Which
distance.
That's why these are here, so that
Yep.
when it hits, it can just push back.
Yep, these are just tiny 3D printed parts. There's this nice Kevlar string to hold it up. That's deployed, like I said, and then yeah, these have been working super great. It's actually just taped on as a hinge. Gorilla Tape's been doing a really great job. We use these as well as a sort of iron sights to help us line up our autonomous. So there's a reference point back here and then up here, and so that we can be centered on the pipe
Oh yeah, look at
while
that.
setting up. It's worked basically every single time so far. It's been actually wildly effective. Yeah. So then it's just a Neo motor here, little small gearbox. Spark Max runs all the way down the drag chain. Yeah, that's about it. It's a super simple system. There's not really a ton to say.
I am so jealous of the fact that you guys have the IGUS chain that you can separate.
Yeah,
I literally just spent like 2 hours last weekend feeding all our cables through energy chain, so I'm very jealous of you guys right now.
Thank you, Nye, for insisting upon that.
Yeah.
Cool. Well, moving on to that, why don't we talk about your elevator? You said you guys have some pretty interesting software controls.
Yeah, absolutely. As part of giving us the customization and especially concerned with Coral on the ground, we have a couple of modes that we can put our elevator into, especially one that allows us to raise the elevator up to account for Coral between us and the reef, allowing us to score even in that case. If you want to go ahead and enable, because of the slope of our end effector, we don't actually need a wrist, and we can do our L2, 3, and 4 set points without needing to change anything. In addition to that, in the case that we do have a Coral on the ground, we have a button here that we can press that brings our set point up 2 inches. We've found that through testing, that's enough that the drop that the Coral will have still gets it onto the pipe. In addition to that, sometimes we've noticed that due to variances in the field, our set points can be slightly wrong. So we've added a mode where we can provide an adjustment on the fly and then set it to the robot, allowing us to kind of trim out our set points. And this works just once and applies globally across all set points. In addition to this, in software, we use the Neo's relative encoder to determine the position of the elevator. And we've written code so that whenever that encoder detects a negative value, it assumes that the elevator should be re-zeroed, which prevents us from overextending and underextending and allows us to be more confident in our actual position. The last feature here that we have is, you can see how it landed, kind of landed slowly. So when the elevator is told to go down, we did not want to slam it into the bottom to increase durability. So the elevator actually goes using its PID positional control to a set point slightly off the bottom, and then using purely a voltage feed forward, we allow it to slowly fall down onto the bottom of the robot. And we've just found this to be a lot nicer to have. We don't want to deal with breaking something or making loud slams during a match.
Yeah, I like that. You don't always see teams taking the time to put velocity control in their elevators, but I mean, clearly you guys have proven here that it's helping you guys out.
Yeah, and especially having that kind of fine control with the hop, not only does that allow us to account for a Coral on the way, but if say we were off slightly and the Coral is stuck between the robot and the reef, just this morning today we've had to hop the elevator up to kind of give the Coral one final nudge. So these features have all been really important to our success.
Very cool, guys. Well, you guys have built an awesome bot. While I have you here, is there anything we should know about your team that isn't represented just by this bot?
We are entirely student designed, and I'd say something like 95% of the parts for this robot, including the holes on the box tube, were made in our high school. The other like 5% coming from our mentors or students' houses. So I think that's a really cool part that most teams don't get to do.
Very awesome, guys. Well, this has been a great robot to look at. I can't wait to see you guys on the field tomorrow, where I'm sure you're going to be Alliance captain.